Welcome back. In this video on simplifying radicals and rational exponents, we're going to be looking at rationalizing the denominator. So our first problem we're going to look at is the square root of 1 over 2. If we remember back, a radical is simplified when the radicand contains no fractions and no radicals appear in the denominator. In this case, we are violating the issue of no fractions inside the radicand with the fraction of 1/2. So what we want to do is first start by separating this out into the square root of 1 divided by the square root of 2. Now I have a radical in the denominator. To get rid of this radical in the denominator, I want to multiply by a convenient value of 1. This convenient value of 1 has the goal of making the square root of 2 no longer appear in the denominator. So if I multiply the square root of 2 by the square root of 2, I get the square root of 2 squared. The square root of 2 times the square root of 2 is just going to give me 2 in the denominator. The square root of 1 times the square root of 2 will give me the square root of 2, making the square root of 1/2 equal to root 2 over 2. So there's our first example, a pretty basic example. Let's look at what happens if we have a rational exponent now. So now I have an exponent of 1/3 appearing in the denominator. In this case, no exponents that are not natural numbers in the denominator. 1/3 is a non-natural number, so it cannot be an exponent in the denominator. To work through this problem, you might think to yourself, what if I just did the same thing I did before and multiplied by this by p to the 1/3 over p to the 1/3? Now, I have picked a value of 1, but we have to decide if this value of 1 was convenient. So if I multiply this out, I end up getting p to the 1/3 in the numerator and p to the 1/3 times p to the 1/3. If we remember back to our properties of exponents, I have the same base. I'm going to add exponents. This will give me p to the 2/3 in the denominator. P to the 2/3 is not a natural number, so it cannot appear in the denominator. So this was the wrong value of 1. It was 1, but it wasn't convenient. So now I want to try again. I have 1 over p to the 1/3. I want to think to myself, convenient value of 1. What should I multiply the denominator by to make this exponent a natural number? Well, remember, if I'm going to multiply it by something, I'm going to add the exponent. So I'm thinking to myself, 1/3 plus what is equal to 1? And in this case, it's 2/3. So I'm going to make that into a convenient value of 1, right? I want to multiply the denominator by p to the 2/3, so the numerator gets the same. So in the numerator, 1 times p to the 2/3 is just p to the 2/3. P to the 1/3 times p to the 2/3 gives me p. So I have that fully simplified. Now, I can look at something a little bit more complicated. In this problem, I'm looking at the cube root of 3 divided by 4x. So I have a radical. A radicand that contains a fraction, so I have an issue there. And I want to make sure that n is as small as possible. The radicand contains no factors. So I want to work through this. All right. My first step with this problem is to separate the numerator and the denominator. So I'm going to end up with the cube root of 3 divided by the cube root of 4x. I need to be thinking to myself, how can I get these out? So what I really need is the cube root of something cubed becomes that something. So that's my thought process. That's my main goal. So I'm actually going to rewrite my denominator a little differently. I know that 4 is a perfect square, or if 4 is a square, it can be written as 2 squared times x to the 1. So my goal is to make the exponent on each of these things equal to 3. So I'm going to multiply this by the cube root over the cube root. So because that's a cube root, this needs to be a cube root. What should be in here to make the exponent 3? What about 2 to the 1? And to make the exponent on x3 would be x squared. So this also needs to be the same thing in the numerator. It's a convenient value of 1. Okay, so in the numerator, this gives me the cube root of 3 times 2 times x squared. And in the denominator, this gives me the cube root of 2 cubed times x cubed. The cube root of 2 cubed is 2, and the cube root of x cubed is x. So I now have the cube root of 6x squared over 2x. That is my fully simplified answer. Another problem we could look at that's a little bit more challenging is this one. 4 to the 1/6 divided by y to the 6/5. We're going to have a couple different things that we're looking at when we're talking about rational exponents. Anytime you see something like 4 can be written as a number raised to an exponent, so I want to take care of that. I also see that I have a fraction in the denominator, and this fraction, a fractional exponent, and this fraction is bigger than 1. So if I look at 6/5, 6/5 can be written as 1 plus 1/5. So I'm going to start by writing 4 as 2 squared raised to the 1/6, and y to the 6/5 as y to the 1 plus 1/5. If I have addition up here, I can turn that into multiplication. I can also use this property to rewrite this as 2/6. So this is 2 raised to the 2/6 divided by y to the 1 times y to the 1/5. So now that I've dealt with this fraction being bigger than 1, I can now handle the fact that I have a rational exponent in the denominator and I can't have that. So I need to think to myself, what do I have to multiply by? 1/5 plus what is a whole number, which is 1. So this is going to need to be 4/5. Again, this is a convenient value of 1. Don't forget, we have to multiply by 1. Numerator and denominator must be the same. So then in the numerator, this 2 to the 2/6, I can rewrite 2/6 as 1/3. So this is 2 to the 1/3. Y to the 4/5 will stay right there. And in the denominator, this becomes y times y. Y to the 1/5 times y to the 4/5. This is y to the 1. 1/5 plus 4/5 is 5/5. So in the numerator, I have 2 to the 1/3 y to the 4/5 divided by y squared. And this is my fully simplified answer. You may notice y appears more than once, and that's okay, because I've satisfied my rules. There are no negative exponents. There are no exponents that are not natural numbers in the denominator. 2 is a natural number. There are no complex fractions in the exponents. And the index of any remaining radical is the least number possible. So I have no denominators. Like here, this index was not the least number possible. So this is my final simplified answer.